All right, welcome to the Explainer. Today, we're going to peel back the crimped seal on something you probably use every day and take a look at the incredible industrial engineering that goes into making it.
Just think about that number for a second. 18 billion. That's how many tubes of toothpaste are made around the world every single year. I mean, an operation on that scale, it has to rely on a process that is just unbelievably precise and repeatable.
And that's because we're not just talking about some simple minty paste. Oh no, this is a really sophisticated, highly engineered product. It has to be stable, it has to be safe, and of course, it has to be effective for literally billions of people.
So how in the world does a bunch of raw chemicals turn into that perfectly smooth paste that keeps our smiles healthy? Well, that's what we're here to find out. We're going to follow the entire journey right from the chemical formula on a spec sheet all the way to the factory floor and the high-speed filling line.
Okay, so it all starts with the formula. You can think of it like a super precise recipe where every single ingredient has a very specific, critical job. I mean, from actually cleaning and protecting your teeth, all the way down to just making sure the paste squeezes out of the tube just right.
Take a look at this. What's really fascinating here is just how much these percentages can vary. You've got abrasives making up almost half the entire product, while the active ingredient, fluoride, is often less than 1%. It really shows you how chemists fine-tune these formulas to get different results, for whitening or for sensitive teeth or just straight-up cavity prevention.
All right, let's talk about abrasives. These things, like hydrated silica, are the real workhorses. They're the ones physically scrubbing away stains. But here's the trick. You have to balance that cleaning power with safety. You don't want to damage the tooth enamel, right? That's where the RDI index comes in. It's a scale for abrasiveness, and the American Dental Association says, hey, keep it under 250 to make sure it's safe. And then you have the star of the show when it comes to preventing cavities, fluoride. This stuff is amazing. It actually works at a molecular level. It performs this neat little trick, an electrochemical substitution, basically swapping out weaker bits of your tooth enamel for much stronger ones. This creates a surface that's way more resistant to acid. I mean, this is the fundamental science behind modern dental care. Now, this is huge. It shows a make-or-break rule in toothpaste chemistry. You see, if you mix the wrong abrasive with your fluoride, like calcium carbonate, they react and form an inert precipitate, basically chalk. The fluoride is completely deactivated before it even leaves the factory. This one single chemical incompatibility dictates the entire formulation strategy, and from an industrial perspective, getting this wrong is a major cause of incredibly costly batch failures.
So, we've got our recipe figured out. Now, let's go where the magic happens. We're heading to the factory floor to see how all these ingredients get combined on a massive scale to create that perfect, smooth paste.
The number one challenge? Viscosity. We're talking about a paste that is incredibly thick. Think thousands of times thicker than honey. Trying to blend that stuff uniformly is a huge mechanical engineering puzzle. That perfect, smooth texture you expect in your toothpaste, that's a direct result of solving this problem. Because if you get it wrong, you end up with a gritty, separated mess, and a whole batch goes to waste.
And the solution to that puzzle is this beast, the Planetary mixer. These machines are really the heart of the entire production line. They've got these super powerful, high-torque agitators that can just plow right through that thick paste. They also have jacketed walls for precise temperature control, which is crucial. And, this is key, a built-in vacuum system to get rid of any trapped air.
This whole mixing process isn't quick. It can take anywhere from 4 to 8 hours, and it has to follow a super strict sequence. You start with the liquids, then you build the gel structure with thickeners, and then comes the really tough part, the most energy-intensive phase, dispersing all those abrasive powders. It's only after the batch is cooled down that the delicate stuff, like the active ingredients and flavors, get added, right before that final vacuum step.
And that final step, the vacuum deaeration, it's an absolutely critical quality gate. The mixer's totally sealed and a strong vacuum is pulled. What this does is force every last little micro bubble of air out of the paste. Why does that matter? Well, if you skip this, your tube filling machine goes haywire, you get inconsistent weights, the product isn't stable, and the customer gets a bubbly, weird paste. It is completely non-negotiable.
Right. So in an industry where you're making something that people put in their mouths every day, quality and safety aren't just nice-to-haves. They're mandated. There's a strict set of rules called Good Manufacturing Practices, or GMP, and they govern every single step of the process.
So before a single tube gets filled, a sample from that massive batch gets rushed over to the quality control lab. There, it has to pass a whole battery of tests. We're checking things like pH, viscosity, and most importantly, making sure the concentration of fluoride is exactly right. If any one of these is out of spec, the entire multi-thousand-pound batch is put on hold or, worse, rejected. A huge loss. And a lot of these protocols are all about preventing errors before they can even happen. For example, you have two-person verification for weighing raw materials. One person weighs, a second person has to confirm it. That's a classic check and balance. Or how about this? Every single barrel of ingredients that comes into the factory has to pass QC testing before it's even allowed near the production line. These are all just layers of protection for the product and, just as important, for the operators. One of the absolute cornerstones of GMP is something called line clearance. So before any new batch can start, a quality assurance officer has to physically walk the entire production line and inspect it. They're looking to make sure it's spotlessly clean and totally free from any residue from the last product. It's a formal, documented check, and it's essential. It's what prevents cross-contamination, making sure you don't get whitening ingredients in a children's strawberry-flavored toothpaste. Okay, so the paste has passed all its tests with flying colors. Now it gets pumped over to the high-speed filling lines, where it finally meets its home, the tube. But this is where the industry is staring down its next huge challenge.
You see, the classic toothpaste tube, that laminate of plastic and aluminum, is a nightmare to recycle. It's just notoriously difficult. And because of that, the whole industry is shifting, and shifting fast. Brands are moving over to what are called monomaterial tubes, usually made from HDPE plastic. And the big deal here is that these can actually be processed in your regular, everyday recycling bin.
And this whole push for sustainability, it goes way beyond just the tube. It's actually influencing the formula itself. We're seeing a big move to sustainably sourced ingredients. And even more than that, we're seeing some pretty radical new product forms emerge. Things like water-free toothpaste tablets. I mean, think about it. They completely eliminate plastic tube waste. And since they're lighter and smaller, they massively reduce the carbon footprint of shipping.
So we've had the familiar paste in a tube for what, a century now? So what's next? What does the future hold for this everyday essential?
Well, innovation is definitely speeding up. We're seeing a huge focus on biotechnology. Think probiotic formulas that work with your mouth's natural microbiome. We're also seeing biomimicry, with new ingredients that perfectly replicate your natural tooth enamel. And of course, like we just talked about, totally new delivery formats that are designed from the ground up for a circular economy.
So it really makes you wonder, doesn't it? With the rise of water-free tablets, these new personalized formulas, and biomimetic repair, is the traditional tube of toothpaste facing its own expiration date? It's a pretty fascinating question. As the science of oral care and our demands for sustainability keep evolving, the product that's been a fixture on our bathroom sinks forever might just be on the verge of its biggest change yet. Thanks for joining me.